Notes number 3, domain range and x-intercepts. When we look at these, the domain range, we talked about that earlier in Unit 2 or Unit 1, one of them. The domain is all of the x values. So all of the x values is your domain, which means the range is going to be all of the y values. So we've already dealt with domain and range, so it's just a refresher of the domain and the range. Domain is all the x values and the range is all the y values. Now the x-intercepts, this is where the graph crosses the x-axis. So wherever the graph crosses the x-axis, that's going to give you your x-intercept. Or these are also called your zeros or solutions. So wherever the graph crosses the x-axis, this is going to give you your zeros or your solutions, or it's also called the x-intercepts. Now when we look at the first graph, we want to find the domain, the range, and the x-intercepts. We know that the domain is the x-axis, so it's all the x values. Well, this is the x-axis. So the domain goes from here all the way over to here. So it goes up and over, but we're just concerned about the x value. So it goes from 0 and it goes all the way over to 9. So the domain is from 0 to 9. So the domain is from 0 to 9. So x is any number between 0 and 9. So x can be 1, 6.4, 3.52, 8, 7, 9, 4. But x can't be anything in the negatives, or it can't be above 9, because the graph starts at 0, stops at 9. And when we look at the range is your y values. Well, the y values go up and down. Well, the y values go from here and go up to here. So the y values start at 0 and it goes up to 1, 2, 3, 4, 5, 6. So the range, it's from 0 to 6. So the range goes from 0 up to 6. It's all your y values. Now, to find the x-intercepts. The x-intercepts where the graph crosses the x-axis. Well, in this case, we have one here, and we have another one right here. So there's two x-intercepts. The first one is at 0, and the second one is at 9. So the x-intercepts are 0 and 9. Now when we look at graph number 2, once again, we're going to talk about the domain first. So the domain is all of your x values. Well, this graph stops right here, and it stops right here. And it continues along that path. So it stops at 1, 2, 3, negative 5. It stops at negative 5, and it continues and goes to 9. So the domain, it's from negative 5, and x is between negative 5 and 9. So x is anything in between negative 5 and 9. The range, the domain is our x, the range is our y. So the range is the y values. Well, the y values goes all the way down here, and then it goes all the way up to here. So the range, it goes in between this area from here to here. So it goes between negative 1, 2, 3, 4, from negative 5 up to 2. So the range is from negative 5 to 2. The way we write that is the range. The y values, the y is between negative 5 and positive 2. So the range is from negative 5, it's less than y, and y is less than 2. Now with these, the x-intercepts, it's where it crosses the y-axis. Well, once again, we have a point here. We have another point here. Now with these don't cross right at an exact point. Well, later on, I'm going to show you how we can use the graphing calculator to find that. But for just now, we're going to say, well, it crosses in between these 2 points. So it's in between negative 4 and negative 5. So we're going to say the one x-intercept is negative 4.5. And then on the other side, it's in between 7 and 8. It's in between 8 and 9. So we're going to say that's 8.5. So we have our two x-intercepts of negative 4.5 and 8.5. Now when we look at the next example, we have y equals 3x squared minus 3. Well, the first thing we have to do is graph this. So let me get the graph calculator. Alright, now with example 3, we have to graph this, so we're going to get the graphic calculator, and we're going to type in 3x squared minus 3, and then we go to our table, and we can plot these points. Well, we can't plot negative 105, 72, so we're going to get down to, we can plot negative 2 and 9, so we have negative 2, 9, so negative 2, 9, and then we have negative 1, 0, so negative 1, 0, and then 0, negative 3. If I keep looking at my table, I have 1, 0, and 2, 9. And once again, if you notice, these points have that symmetry where these will fall on top of the other ones. So we have our graph. Now the domain, once again, the domain is all of the x values. Well, when we look at this graph, the x is always going to keep going. So it's always going to keep going to the left, and it's always going to keep going to the right. So the graph of this one is all real numbers. So we have all real numbers. The reason the domain is all real numbers is because this graph never stops going to the left. These values will keep decreasing. The x values will keep decreasing, and it never stops going to the right. They're always going to be increasing. So the other way that we can say all real numbers is we can make a fancy R. Now, when we look at the range is our y value. So the y is up and down. Now, if you notice this graph, it's going up, but it stops. It has that minimum point, so it stops down here. So it starts here and only goes up. So the y value is anything that's greater than negative 3. So it's from negative 3 and up. So the range is y is anything greater or equal to negative 3. So the y value is anything greater or equal to negative 3. So since the range is the y, it has that lowest point of negative 3, nothing below it. But the domain, the x, can be any number. The zeros are the x-intercepts. It's where it crosses the x-axis. We have two of them. So it crosses at negative 1, and it also crosses at positive 1. So the zeros, or the x-intercepts, negative 1 and positive 1. Now at the vertex, the maximum, minimum, and axis of symmetry, well, we can find the axis of symmetry using our formula. X equals negative b over 2a, where we just plug in the b and the a. Well, b is 0, so we get negative 0 divided by 2 times 3, and that's going to give us 0. So our axis of symmetry is x equals 0. Now if you notice this graph, make this, here's our axis of symmetry, which is this line that divides this graph right into half. There's our axis of symmetry, x equals 0. To find the vertex, we take this x equals 0 and we plug it in. So we have y equals 3x squared minus 3. Y equals 3 times 0 squared minus 3. Y equals negative 3, which means our vertex is 0, negative 3. And if you notice once again, if I look right here at 0, negative 3, that's where the graph turns. And that's also our minimum point. So the vertex is a minimum point. So the minimum point is also the vertex. So if we graph it, we're going to start being able to find the vertex just from a graph. And we won't have to use the formula anymore. So if we look at example number 4, we're actually going to change this minus 12 to minus 5. Should make the graph a little bit better. Hopefully it'll fit onto our chart. So if we do x squared plus 4x minus 5, look at our graph. So now we have our graph here. So we can see the graph, and we want to plot our points. So we go to second graph, we look at our table, and we plot our points. So we can't plot 16, so we can start with negative 6, 7. So we have negative 6, 7. So we would go negative 6, 7. Then we plot negative 5, 0. Negative 4, negative 5. Negative 3, negative 8. Negative 2, negative 9. And then we plot negative 1, negative 8. 0, negative 5, 1, 0, and 2, 7. And we draw our graph. If I went too fast for you, you can always just pause it and catch up and plot your points. So now when we want to talk about the domain is all of the x values. Well, if you notice, this graph is never going to stop going to the left. It's going to keep going and going. And it's always going to keep going to the right. So the domain is all real numbers. Or we can use our fancy eye. But the range are y values. If you notice, this graph stops going down. Well, it stops at negative 9. So it starts at negative 9 and it goes up. So it stops going down at negative 9, or it starts at negative 9 and goes up. So the range is when y is greater than negative 9. The next thing we want to do is find our zeros, or the x-intercepts. We have one right here, and we have another one right here. So we have negative 1, 2, 3, 4, 5, and positive 1. So the zeros are the x-intercepts, negative 5, positive 1. Now to find the vertex and the axis of symmetry, we can do one of two things. We can look at our minimum point and say that the minimum point is negative 2, negative 9. So the minimum point is negative 2, negative 9. So this is negative 2, negative 9. So now when we go to find these two values, axis of symmetry is x equals negative b divided by 2a, which is negative 4 divided by 2 times 1, which gives us negative 2. So the axis of symmetry is x equals negative 2. If you notice, we draw the axis of symmetry. Here's negative 2, to where the graph splits in half, and it goes to that value. And then to find the vertex, we plug in negative 2 for x, so we have y equals x squared plus 4x minus 5, so y equals negative 2 squared plus 4 times negative 2 minus 5, y equals 4 minus 8 minus 5, which is y equals negative 9. So the vertex is negative 2, negative 9. Now notice that's the same point that we got from our graph. So the vertex is that turning point. So whatever that turning point is the vertex. And the axis of symmetry is always going to be the x value of that vertex. And when we look at it, we know that this is a minimum value. So now we talked about 3 more properties of our graphs. We talked about the domain, the range, and finding the x-intercepts, or the zeros. And we also know how to do the vertex, maximum, minimum, and the axis of symmetry. And that wraps up today's lesson.